Up to now, you should have learned the basic skills of resolving forces, summation of forces, a calculation of moments and doing its summation, as well as the drawing of free body diagrams. We are now going to look at the conditions that keeps a body in equilibrium. Now here we have a rectangular body with 4 forces acting at one of its corners. The resultant of these 4 forces must equal 0 for balance. And this will also mean if the forces are resolved along 2 perpendicular axes, the sum of the forces along each of the axes must equal to 0, or simply put, the opposing forces must balance. Now to make it easier, let's put in some values for the forces. The algebraic sum of the y component forces, which is 8 plus 3 minus 11, equal to 0. And similarly, for the x component forces, is algebraic sum 7 minus 5 minus 2, also equal to 0. So for equilibrium, 2 conditions must be there, and that is the sum of forces along the y-axis must equal 0, as well as the sum of forces along the x-axis, which is perpendicular to the y-axis. It must also be equal to 0. Now, but do note that in this case, the forces are concurrent. Now, what if the forces are not concurrent? Let's now make changes by putting F1 and F3 at the left corner of the rectangular body. Now the forces are now spread out, so they are no longer concurrent. That is, they no longer act through a common point. Now how will these affect the equilibrium? Now clearly, the summation of the y component still equal to 0. And the same can be said for the components in the x direction. So does this mean that the body is still in a state of balance? Let's check it out. Have a look at the vertical forces at the left corner. Now we now have 3 units of force pointing downwards at the left, and with 3 units of force pointing up on the right. And we now have an anti-clockwise couple. So the body is no longer in equilibrium. And we will need a moment in the opposite direction to restore the equilibrium. So let's try shifting the 2 units downwards like this. And now we have a net force of 2 units at the top edge of the rectangle. So what we have done is we have just created a clockwise couple, which is going to counteract the anti-clockwise couple caused by the 3 unit force. And now the moments can be balanced, and the body is back to a state of equilibrium. So for a non-concurrent force system, where the forces are spread out throughout the body, force balance alone does not guarantee equilibrium. We need the sum of the moments to be 0 as well.